Hi, welcome to your tutorial number 9. In this tutorial we're gonna complete the review chapter 6 from the textbook. You remember in tutorial number 7 we did not finish with the PowerPoint, and then after that we were working with Visual Basic in defining some variables so the buttons will have some functionality in the calculator. So now let's go back to the PowerPoint and go with the section 6.4 from the textbook that says memory concepts. When we're defining a variable, I said that before, what we're doing is that we asking for the system to allocate some memory. You remember also from chapter 1, one of the parts of the computer architecture, we said that the computer has an input devices, output, but we also say that it has some memory, which is the one that we use, which is actually the working memory, where the computer actually executes the program and loads the information. And we got also the long-term storage, the hard drive, the flash drives, and all of those. That from that we load information into the memory. So here we got certain amount of memory available, and the memory is the we use bytes for the space in memory. Then the allocation, we said, okay, I need to define a variable and ID this number of bytes, and in that please be sure that I'm gonna be allocating this type of information, like an integer, a float. Like in my example, we were working with a float number, with a no, we were using, wasn't a float, was a double. We were using a double. Okay, it's always giving me a hard time to move to the next transparency. Okay, now in your chapter they have an application, and you remember the application that they have there. So they just illustrating, okay, we're reading the content, and then here using the val function again to place that into that variable. And then it says, okay, how that is gonna be. The what actually reading from the text box is a string, and the variable is expecting, I think, an integer. If I remember from here, yeah, you see on line number 7 the definition of that variable is an integer. So here this is a good explanation that says, hey, you know what you're reading from the text box is a string, is not the same, but it says, okay, this is being converted into an integer when you use the val function, and we discussed that previously. This is a nice figure in which they kind of visualize, how is that, okay, we kind of see that there is a cell in memory, and then the cell has a label, which is the name of the variable, and then inside there is a content, which is the number 12, assuming that the user typed a number 12. And then something important is the concept of overriding. So in this case, for example, we're assuming that the content of that variable is a 12, but then if the user types something else, then the previous value is going to be gone, it's lost, it's overwritten, because we're going to have a new value. Why? Because we only have a space to store one value. So whenever we do another assignment, then the previous value is lost. In our examples, in the example that I just did with the calculator, you remember the variable total, I was holding a value, and then when the user presses the plus and then the equals, remember, when I presses the plus, I store on total the value that is on the screen, and when I press the equal sign, I go and retrieve the value from total, add with the current value of the screen, and then I replace whatever is in total with that new value. So that's what I'm doing there. Okay, now something important about assignments. This is also a common mistake. So for example, here is an assignment of variable x equals to a plus b. X is the value of x is the one that is changed only. A and b are not changed. We're reading the value of a and the value of b. Okay, and whenever we make an assignment, in the left hand side of the equal sign, there should be just one variable, and then we can have what we call an expression in the other side. So in this case, it says x is going to be the same as whatever is a plus b. Okay, now this is the next section that is important in the book. The most of them will gonna be kind of obvious, but there's gonna be just one of the two operators that I think you need to review at least twice. So what type of operators do we have available in Visual Basic to perform basic arithmetic? Basic arithmetic is adding, subtracting, dividing, and multiplying. Okay, well, here this table on figure 6.15 from the textbook, it says, well, we got addition, subtraction, multiplication, and division. Good. I think that was expected. However, look at that, we got two types of division. One for float numbers, which means numbers that got decimals, and division for integers. And then something else that is going to be really useful is the one that they call modulus, the one that they define as the MOD. So those two operators are the one that we should review at least twice. Okay, you should check on those, and I'm gonna give you some examples. And actually, the next posting is based on the modules operator. So we got the exponentiation and the to define negative numbers or positive numbers. You put that before. Okay, now in 6th or 7th grade, we all were working with order operations, which we're gonna review that soon in this book. But let's go back with the two type of divisions. So dividing two numbers and dividing integer division. So let's see, the results from those is going to be either an integer or a number that has decimals. But let's look into the examples and see. Let me see, there is something with integers. Okay, so when we divide two integers, we get the integer result. Let's say I was looking for an example here. I don't think I have an example there. Copy that from the book. Okay, so if we divide, for example, 4 divided by 3, the actual result should be 1.333. But if we're doing integer division, it will be just 1, the integer part of the division. Now, when we do floating point numbers, it says there that there are two ways of rounding. So it says that when ends with a 0.5, so it's not necessarily the same thing that we were checking in algebra. So look, when it's an even, it goes to the nearest even number. So in this case, 6.5 equals to 6. And in algebra, we were told that 6.5 rounds to 7, right? But here it rounds to the closest even number, and 7.5 rounds to 8. And then you can check on the other example. So that's the section with when the number ends with a 0.5. And I think, and then again, we know that division by 0 is not defined. We know that also in algebra, that we cannot divide a number by 0. It will give us an error, so we need to be sure that that doesn't happen in our programs. Now, this is something that is really important, and this is going to be very useful. So if we do, when you do long division, I think from 4th grade, remember you were doing, for example, 7 divided by 4, like in this example, in the long division, there is something that you call the remainder of the division. So the remainder will be, you divided 7 by 4, it will be 3. So it will be 7 divided by 4 is just one time that you can divide 7 and 4, and then the remainder will be 3. The same way you divide 17 by 5 will be 2. So the most common use of this is when to identify that a number is a multiple of another number. Like for example, if I divide 15 divided by 5, the remainder is going to be 0. So every time that I got a remainder equals to 0, it can be interpreted as I'm dividing by something that is a multiple. In these transparencies, I just have the information about that. We define expressions like the same way that we do in algebra. We just have we do that in a single statement. We can group the expressions with using parentheses when needed. So for example, at the bottom of this transparency, we got a times b plus c. We take away the parentheses, it will say a times b first and then plus c, which is not the same. So this comes from algebra, that we were supposed to be checking since we were in 7th grade, what they call order of operations. So and the same thing, they're going to be applied left to right. I think we can review, you can review that, you can read on that. I don't think they should give you any problems understanding this. From here I think it's the same rules that we get from regular math, and these are examples of how it can be implemented or how this can be transformed. So this example in algebra, like the one to get this law, for example, well, these are two good examples. M equals A plus B plus C all divided by 3. How can we implement that in Visual Basic? Well, you do the A plus B plus C in parentheses and then you divide it by 3. It's just to say, well, we don't have exactly the same symbols, like down the, and then here y equals m times x plus b, we need to be explicit and say y equals m and then the times symbol x plus b, and in the rules. And then here is just to have understanding of the order of operations. What is it that is going to be performed first? So here it says that the one with the highest precedence will be the exponentiation, so x to the power of 2 is going to be implemented first, then multiplication, and then from left to right we got addition, so it's going to be well, I got another multiplication, which is number 3, and then 2 additions, and when there are 2 at the same level you do that from left to right, and then finally you do the equal sign, which you get the answer. On my next tutorial I will give you an example on how we gonna have the next posting in D12. So again, if you have any questions, please post those in D12 too, and we have. And then this is just a good programming practice that the textbook recommend to use parentheses when, I mean, we don't want to have any type of confusion in the order of operations. So here it says it is acceptable to have redundant parentheses. Redundant, that means they're probably not really needed, but I mean it's a safe practice. Just gonna end this. Let me see. This is the last one. I just gonna end this with the code that they got on figure 6.1, and let's see. So in figure 6.1 they got something about what happens when the user changes the text, and then you see there is a on 22 to 30 there is a procedure that when they click it, the only thing that they're doing on 20A, it says that the text in the label total is going to be changed for the empty string, and the same, they show the same on 36. I don't think this is going to be clear from this, just looking into this figure. So on the next tutorial I'm going to explain, I'm going to have 2 more tutorials for this unit. So I'm going to have one on explaining the bend of text change, and then another one on explaining the next posting. So just look for the next 2 tutorials. Thank you.